So these are problems that are quadratic in nature, and all that means is after we do a little modifying, they're going to be quadratics, and then we can use the square root property or quadratic formula. So what we're going to be using is a little thing called u substitution. So we're going to take a u, and you're going to pick the middle term. Make sure it's in descending order, and we're going to call it x squared. Okay? So if you look at this now, this right here would now be u squared minus 3u plus 2 equals 0. So we've modified it into a quadratic. And you're asking, well, why does that work that way? Well, look at x squared here. We just called it u. So if you take the middle term, that's normally where our x would go. So we call it u equals x squared. And then we just verify that at the very end, this number here is double that one. So if I were to take and square both of these, I would get u squared equals x to the fourth, because u squared, I get that. So that allows me to take my x to the fourth and replace it with u squared. So as long as this exponent is twice that exponent, we can think of it as a quadratic and use u substitution. So now we have our u, and all we do is solve this. So this is factorable. So we say u, and what two numbers when multiplied give us 2, when added give us -3. That would be -2 and -1. And we do a quick little check. So that's 2 and -3. So if we had -1 and -2, they both multiply to give us 2, and they add to give us 3. So that works perfectly. And then we separate them. So u minus 1 equals 0. U minus 2 equals 0. So u equals 1, and u equals 2. Now with u substitution, all we did was use the u to modify it into a quadratic to make it easier to factor and solve. And then now is part 2. We just replace the u back with the x squared, like that. See? And so now we can solve these for x, and these are the answers we're looking for. So it's a quick way to modify. Remember, plus or minus, plus or minus. So we get x equals plus or minus square root of 1 is 1, and x equals plus or minus the square root of 2. And those are our 4 answers. Notice this is a degree 4, so we should be getting 4 ounces down here. They may repeat, but we should still have 4. So 1, 2, 3, 4. So that's what we're doing on each of these. You're going to take that middle term, and they're just warm-ups, just getting used to this now, and replace it with square root of x. And then you're going to verify that this one is twice that. So if we were to take the u equals square root of x and square it, we get u squared equals x. So that allows us to replace the x with u squared, the square root of x with u, and then we bring the 4 over, because remember we want these to equal 0. And there we go. And then we try factoring, and if factoring doesn't work, we use quadratic formula. So we do 2u, u, minus 4 and minus 1, and then we check. It's 2u squared, minus 8, minus, that's -9, and then plus 4. So it works perfectly. And then we say 2u minus 1 equals 0, u minus 4 equals 0. It's about to write the answer. So u equals 4, and u equals 1/2. And then we go back now, and our u, again, was a square root of x. That's our main focus, these guys right here. So we're going to replace it and put it right back in, because we're not solving for u, we're solving for x. Okay, and then how do you get rid of a square root? Well, we just square it. And we get x equals 1/4, and x equals 16. Or you can write this as a decimal if you want, your choice. But those are our answers. So let's go back and write our solution set here. We have negative square root of 2. I'm going to put them in order. -1, 1, and square root of 2. And then over here, we have 0.25 and 16. And then we just have one more. So again, all you're doing is looking and making sure that this one is double that one. So like if you just look at it, if I just scratch this off, see? You see this quadratic sitting right there. So we just have to say u is the middle term, 1 cubed. And make sure it's always in descending. So like this was 1/2 and then no x, 4, 2, no x, 2, 1, no x. The last one should always be a constant, no x. All right. And you're saying, well, what if it doesn't have that? Well, then you don't get to use this. It's just the way it is. So you have to try a different trick. So now we try factoring this, and so this one's nice and quick. We get positive 3 and minus 2, because those are the two numbers that add up to give you negative 6. When added, give you 1. And we get u equals negative 3 and u equals 2. Remember, we just switched the sign. That's all that's happening here. And we then plug it back in. See, you can get really quick at this the more you practice it. And so how do you get rid of a third? Where over here we've had a square, and so we used a half for our exponent. This was a half, and we used a square. You just use the reciprocal. So the reciprocal of a third is 3. So if you had 2/3, you'd use 3/2, because that way it cancels. Remember, this is multiplication here. So you're getting x to the 1/3 times 3, and they cancel, giving us just x. So we got to cube both sides. So that would give us negative 27. And again, those cancel. And this would be 8. So our answers would be negative 27 and 8. And now there's a lot going on here. So you always want to check with your calculator or with Desmos. So I've already plugged them into Desmos. We should be getting these 3 answers. These 2 for the middle and those 2 for the last. So let's check with Desmos. So here we go. I've plugged in that equation, and you see it's negative 1.41, 1.41. You're like, well, I don't know if that's square root of 2. Just plug in square root of 2. It says it's 1.41. So yes, that checks perfectly with what we wanted. And then now let's check our middle number. So I've brought everything over to equal 0, just like we had to do here. Let's click on the graph, and it says 0.25, and then the other one is 16. Checks perfectly. And then the last one, we should get those 2 answers that we wanted. Let's click on the graph. First one's 8. That was correct. And the other one's negative 27. Yep, there it is. So see, negative 27 and 8, 1/4 and 16. Everything checks. So that's how you solve with u substitution. Just make the middle term your u, replace it, make that one the square, verify that you have to double it or square it to make sure it matches. So even the last one, we didn't really check it. Let's double check. So if I square and I square, I get u squared equals x to the 2/3. So check, check, and check. Everything works perfectly. Check with Desmos at the end or your graphing calculator.